forgot to take an explainer today, so today we'll be explaining bitwise shifts and these three funny shift symbols. So what is a bitwise shift? So these are operators in programming languages like C, and they are used to manipulate bits. So let's say you have 001110 and you have a 110011. Ooh, okay. So what do these actually mean? This is a binary number if we consider this to be the LSB, so this is least significant bit, and this is the most significant bit. Then we can convert this into binary as such, so this will be 1, 2, 4, 8. So it's a 8 plus 4 plus 2 equals to 6 plus 8 is equals to 14. However, the funny thing comes when you have a leading 1. In computer systems, normally the first bit is used as a sign bit. However, there's something more unique called a 2s representation. You don't need to know what that is, but basically it shows that the first bit is actually a negative sign if it's 1. So how does this affect what we are doing here? The shift allows you to shift the entire string of bits. So let's say I wanted to shift this by, let's say I want to left shift by 1. I'll just add a 0 at the back, so it becomes 00111100. So I shifted by 1. If I want to shift it by, let's say 3, I can do 0011100000. So then you can see what is right shift. Okay, actually there's a mistake. It should be right. So if you can guess what right shift does. If you right shift something, it does in this case, let's say right shifted by 3, you just shift everything back to the right, so it actually becomes back to this. However, the funny thing comes when you're trying to use something with leading 1. If you wanted to shift to the right, what do you replace on the left? Because if, let's say, if you replace it with 0, you can do 0110011, then the leading bit is different, and thus that sign of your numbers actually changed. So that necessitates two different things. One is called the logical right shift, and one is the arithmetic right shift. So these have two different operators. This is the logical right shift, and this is the arithmetic right shift. So this preserves your leading bit. So if you used a logical shift, it would add a 0. If you use a arithmetic shift, it will leave a 1. So yeah, that's the difference between arithmetic right shift and left shift. And if you wanted to see this is a non-existent arithmetic left shift, and you can see why that won't be useful, because when you shift in from the least significant side, you always want to add in a 0. I'll leave you to think about why that's so. A hint is to do with multiplication, because shifting by the right by any number actually just times it to the power of 2 to the number of n. Yeah, good luck. This, by the way, this is actual back of the envelope math.